Okay, good morning. Hello, everyone. I hope you've enjoyed the sessions so far. Me and Bazlur, we're going to speak about Java with large language models, the theme which you probably have seen throughout. We're just going to add to it. We've been working on learning large language models, like most of us, for last couple of months or maybe a year or so. And we put down together some exercises, etc., some demos on how you would cater for different things. So today we're going to show some of them, not all of them, so they make sense. And we use JakartaEE and LangChain4j for that. So that's what this talk is about. You'll learn about MCP, you'll learn about RAG, you'll learn about basic prompt engineering, etc. And yeah, feel free to ask questions. Maybe you want to introduce yourself, Bazlur?
Well, can you hear me? I think it's mute. Hello. Okay, so I'm Bazlur Rahman. I'm a Java champion. I'm a Java developer, and yeah, I write books, articles, and oh, sorry. Yeah, hope you can hear me now. So yeah, that's about me, pretty much.
Yeah, and my name is Syed Shaaf. I'm a developer advocate, and yeah, I work with Java for a very, very long time, so happy to be here and share some knowledge. This is the link to the Slido where you can ask questions, so please do ask lots of questions. We would be happy to give some answers as we can. In the most simplest form, you have a large language model, you have a chatbot client, which is the most easiest use case. So in today's demo, you will see so much of chatbot that I promised that at the end of it, you would not want to see a chatbot again. But so what we do is, we are prompting the large language model. We get answers from it. That's the basic sort of chat application. It does not have streaming, so you would add streaming. You'll see that in our demo that we have the streaming options as well. And the backend is sending the information to the large language model. So the chatbot is more like just built with plain HTML and JavaScript as well, using a large language model, by the way. So that's a very quick introduction of how the basic interface looks like. And then let's just start digging deep into it. We are not going to present more slides. I mean, we agreed that we're just going to show you the code, so we're going to get started there. Bazlur, you want to go first?
All right, so this is going to be really demo heavy. So you will see lots of demo, mostly with the LangChain4j, and we are using JakartaEE as a runtime, but that's not gonna see what you are gonna see. Basically, we're gonna explain what is LangChain4j and how we're gonna interact with a large language model. It can be anything, Gemini, OpenAI. Most of our demo is written on OpenAI, but you can just replace the model. It's simple. So I'm gonna start with the basics first, how we're gonna organize our project, and then I'll show you some demos. All right, thank you for helping me.
Yeah.
So for starter, we created a structure for our project from this starter.jakartaEE. As you can see over here, we have selected some options, Jakarta version, Java standard editions, and runtime. It not necessarily we have to use JakartaEE. We can use any framework. You can use Spring, Quarkus, whatever you feel like, because LangChain4j, pretty much all the frameworks now have some sort of integration with extension with LangChain4j. So what we are gonna focus over here is this class. So LangChain4j is basically a framework that provides the abstraction. That way we can communicate with any large language model. So that's abstraction, essentially what we need to know. And over here, we have like a class called OpenAI Chat Model. So it's a nice builder pattern over here. As you can see, you can config all these things. You need an API key, of course. So essentially, you can go to the OpenAI website and create API key, and that's all you need. And you can specify a model name. We configured it. We added a few other things, for example, temperature, top P. These are the configuration that you can do and specify and control how you're going to control your output, input, all of those things, how many token you are going to use, all those things. So essentially that's what it is, and then that's it. So all the configuration we need is here, and you can essentially communicate with this in method, which is chat. So you can send a message and it will respond. Essentially that's what it is. And for this particular demo, we have WebSocket communication. That's abstraction we not need to explain here. Basically we have a chat interface like this. I can show you. So this is the chat interface that we have right now. So you can we can write and it will send back. So this communication from the front end to back end, it happens over the WebSocket. So we know our WebSocket, so that's not gonna, I'm not gonna explain that, hopefully. So that's essentially it is. So if we send a text, it comes here and it calls this method, which is chat over here. And it gets a response and we display over here. So that's the first part. And as you can see, we have created a pretty much extensive demo. We have like 11, 12 demo over here, but we're definitely not going to cover all of them here because it's time expensive. So what we're going to start with the prompts. First one. So the idea of prompt is how we're going to control the behavior of this prompt, because if you send anything, it will respond, right? But for a business cases, you need to configure the behavior. Like this is how you want to get the response. So that's what it is. So over here, as you can see in the demo, we have certain options over here. For example, this is the casual chat. The idea is if we send anything, it will just respond. And it doesn't have to be any specific. Hey, how are you? Something like that. So as you can see, it's respond. I'm doing well. Thank you for asking. Now, so if we want to change the behavior of it, like I want to have a specific behavior. For example, over here, I have a prompt called JChampion, and if I ask, it will, it will respond differently. So before going there, showing you demo what we did over here, let me explain that. So there is a, prompt over here. As you can see, we have added a system prompt over here. There is two things we need to know. We can specify, behavior of a communication to LLMs via system prompts. The idea is we specify how it's going to behave, and then the system message is essentially what we send to the LLMs. So these two things we need to remember. One is system prompts, and another is user prompts. User prompts is basically what you're going to write on the chat. So over here, as you can see, it says it's a sarcastic Java champions tone. We specify the tone. It's going to be sarcastic, humorous, and there are some use cases over here. So let me show you the demo first. Let me say who is the best Java champion. So let's see what it returns. I guess I don't need to increase the font. As you can see, so it returns something, but it's a bit of hilarious. And if I write something like, hey, what is the single tone pattern? So as you can see, it's also going to return hilariously. So the idea is the way we specified the prompt over here with the system prompt, that's how it's behavior. But then what it is going to return is the system message that we're sending. So how we did it differently from the other one, it's simple. So we have a LangChain4j offers a abstraction called AI services. So that's I'm going to show you in a minute. So over here, I think, LangChain4j, yeah, so over here. So as you can see, earlier we showed you a OpenAI chat models. Over here, we have a OpenAI streaming model. The difference between these two is the first one earlier that I showed you, it takes the message and send them all at once. But this one is basically streamed. It keep on sending. So that's the difference, and everything else is same. API key and then a model name and all the other things. But additionally, we have a class over here. So we use because we have a few of them. So it's basically abstracted over here. So we have a method called AI create personality. So we provide the class name and the model that's we build over on top of it, and then we call this a service builder.class, and then over here we use streaming chat model language. That's it. So that's the personality. I mean, that's create the the communication. You can think as a interface like Spring Data or Jakarta Data, right? You specify your intention, and then everything is taken care of by the framework, all the abstraction, all the necessary injection, everything. So that's essentially what it happens over here. So we have a few of them. Like this is one is the casual chat. I mean, it doesn't have any specific. It just is going to be having a conversation with you. Then there is one called chain of thoughts, Java champions that I showed you demo. And then there is movie summarization. So basically, there are other one is poet. That's going to spit out poetry, whatever topic you provide. So let's say let me show you a demo quickly. So sorry, website got timed out.
Can you write a poem about GeeCON?
Yeah, let's try. Let's try that. Let's see. Okay, can you? Write a short poem about GeeCON. Let's see. So as you can see, it's wrote 4-line poems about GeeCON. I'm not sure if it's accurate, but yeah, it's spit out something. So that's the idea. That's the prompt. You specify your intention with the interface. You create an interface like this. It can be anything, and then you specify with these 2 annotation over here, system prompts, and then port it on the AI services, which is I showed you over there, and that's it. Everything is taken care of by the framework. So that's 2 things. Now I'm going to move on a different next topic, which is there is another interesting part of it that we can include, which is memory. So over here, as you can see, it can respond a text, whatever we ask questions, but it doesn't remember the previous conversation. So for a communication to happen smoothly, effectively, we need to remember the previous context, right? So for example, hey, what is my name? It is obviously doesn't know, but it creates a poem about this. So basically, clearly, it doesn't have any context, what I'm saying. But it just knows the current context. So we can change that behavior by 1 line over here. So I'm just going to share that because I use this memory API for the next other demos. For example, over here, as you can see, we specified a memory provider. And there's a few options. Over here, I'm using message window chat memory provider. So you can store in memory, or you can store in database. Over here, we are using in database. We're using Postgres database to store the previous conversation. So what happens is, as you can see, I created a AI service with the Java agent. This is our Java agent. This is a bare minimum, pretty basics. And then we pass this into builder method. And then we also using streaming chat language model that we created earlier over here. It's the same for pretty much all of the demos. And then we also added a chat memory provider. Now it will remember the previous context. So so next step, we created it in a way so that if you follow all the demo 1 by 1, so we started with the basics, and then we keep on adding layers. So we'll share the link of the our GitHub project. So if you follow all of this step 1 by 1, it will. We hope that you will get a good sense of what is the framework LangChain4j offers, and how can we use in our real life Java applications. That's the intention. So next step that we're going to show you is called tools. The idea is, the LLM models can do a lot of things, but it has a limited context, right? For example, your business applications have your own set of knowledge base, your database, and all those things. It doesn't, so LLM doesn't have ability to query on your internal database, right? But we can provide a way to LLM that if you need certain information that's not available on your context, you can access those information via a function calling mechanism. That's called tool. So over here, we have specified a few tools. For example, this one, it's a pretty basic one. This is how we specify the tool with the annotation called tool, add tool, that's it. So we write a method, that method is going to be invoked when LLM thinks this is required. So, and we can provide the hint. For example, over here, we provide the description, return the content of a web page, given the URL. So if we paste the URL in the chat message, and LLM will sort of understand that this is the URL that I need to fetch, so I'll call this method. So this is, then this method will invoked. And the changes from the previous one, like as you can see over here, the chat model is same. It doesn't have a lot of, it's just configuration. And then we have over here AI services, and we provide the interface that gonna communicate with us. And then we provide the model, and also we specify all the tools. So over here we have 3 tools. I'm gonna show you quickly one by one. So let's start with the first one. I have to restart the project step. Bear with me. 03, sorry. So sorry about that. This is gonna take a minute, but while it's running, I'm going to explain. So this is the first one, first tool, and we can specify as many tools as we want, one by one. It's not that they're gonna invoke all of them at once. LLM will decide which tool needs to invoke. So over here we have another tools called Java compiler. For the fun, for the sake of demo, I created this one. So this one is interesting. What it does is, if you put a Java code in the chat box and ask it to compile it, it will compile it, and then you can ask it to pretty much run it. Also, there is another one called this is the run one, and then there is another one for Java+LLMs if you want to deassemble the bytecode and understand the bytecode. So for fun, I created this one. So as you can see, it takes a few parameters. For example, first one, I specified with the annotation tool and then provided the descriptions. The idea is compile the provided Java source code and return the resulting bytecode. And then what it will do is it will store the bytecode in a file. And also, as you can see, it takes a parameter which is source code. So we can specify that. And there is another one which is I'll get into that in a minute. But let's demo this one first. So first one is going to be, so if I type over here, hey, what is the last article I have written on my blog, bazlur.ca. Let's see if it can fetch the information, right? It says I'm unable to access external website. Interesting. That's not supposed to happen. Am I running the right one? So let me see if I'm running. Yes, I'm running the right one. Okay, so let me try it again. Essentially, that's if you don't specify a tool, if you just communicate with a large language model, it can be Gemini or anything. The response is valid. The response is supposed to be like this because the large language model usually can't access external content, but since I specified the tool, it should be. So let's see. Let's try it again one more time. If it doesn't work, we'll move on. You'll just believe what I've said.
Yeah, it's a bug. You need to ask about my web page instead.
All right. So let's try again. So let's try again. Let's see. Looks like this time it's gonna work. Yes. Okay. So this time it worked. As you can see, it in fact fetched the content of my blog post, and it in fact send me a result. So what happened is internally it went on a as you can see over here in the log, as you can see, fetching the content from bazlur.ca. So now let's do the next one. Okay. So can you write a simple Java program that can sort numbers? So obviously it can. It says it's a built-in functions, Okay, that's fine, but it's still a valid Java program, right? So what I'm gonna ask next is, can you compile and run it? Okay, so it's sending a lots of responses. As you can see, it's also streaming, right? So we can use both, streaming one and simple one as well. So can you, compile and run it? So as you can see over here, I specified like, can you compile and run? It knows the context, right? It knows the previous chat history because we applied the memory configuration over here. So as you can see, it compiled and ran, and it returned the result. And I can also sort of, what I can do, we can deassemble if we understand the bytecode. Hey, can you show me the bytecode of it? So it will invoke the specific, specific one. So that's essentially it is. As you can see, it's now going to spit all this bytecode. So you can then ask a specific question about this. So that's how we use function calling. It just enhances the capability of a large language model. So if you let's say if in your business applications you need to access some information from your database, you can create a tool like that, and it will call a function, and function will result the data from your database. So something like that. So it's useful when you are for example, if you have a bookstore website or an e-commerce website that's usually is interacting with you, and there's specific information need to require from, pull from database, so the tools can help with that. So for the fun to be continued, I have created another tool. This is a bit of a large one. So the idea is initially when I started the project, I showed you this one, right? This website. So what it does is you can specify all this information over here, which JakartaEE version you're going to use, profile, standard edition, all those things. And then if you click over here, it can give you a project like this, and you can start on top of it. It's a basic structure of JakartaEE applications. So same thing, I wanted to reproduce using tool over here. So yeah, that's what it is essentially. And as you can see, I provided all the context it requires. Provided the descriptions, what are the parameters we require, and how this parameter is going to break down, right? So all of them, and then essentially it takes all of them and then it generates the same thing that the website does. It does locally, by the way. So we're gonna do it the same thing quickly, and let's see if it works. So I'm gonna refresh this page. And I'm gonna write over here, hey, can you generate a JakartaEE project for me? So as you can see, it says sure, to generate JakartaEE project, he needs all this information. So it's also, it takes all this information from the parameter we specified over here. As you can see, all these parameters, right? It needs all this information. So it will ask all this information until it is happy. So I'll start with one specifically. One is 11. So let's say one is 10. Two is, let's say, course profile. 3 is 17. And I just provided the 3, right? So now it's asking me the, other information as well. So runtime.
Just use defaults.
Yeah, let's use wildfly and use rest of them defaults. Let's see what it does. So we have specified also default one. So now it's going to use all the defaults one. And let's see if it can do what it's supposed to. As you can see, the console is pretty busy. Because it's doing a lot of things. That means it's working, right? So it takes a bit, because it's basically invoking the local Maven archetype generator from Java. So it takes a bit of time, but it can do that. So hopefully, as you can see, it's created. So now I can essentially click on this link and download it. And it's the same project that we created earlier. So that's how we can leverage the tools to integrate in our own business cases, and if it requires to access our own internal data set, it can be database, it can be some functions, it can be anything, right? You can integrate that, and for that, it's pretty simple. You just specify over here to all the tools you need. That's only one line you need to configure. So that's all for the tools, and I will hand over to my friend. Sorry, I ate up all of your times.
You also ate up my hand. I can't keep it up now. Just kidding.
All right. So we're gonna show we're gonna see some more interesting demo from him.
Okay, so here we are. Let me just put the slides on here. So yeah, so in the second part here, so thanks for the demo. So interesting stuff with tools. We're going to continue tools in the end, hopefully with MCP, and kind of make the distinction between how and what they are and how they're used. I'm going to talk a little bit quickly about RAG. Going to give you a little bit of demo around that. And like I said, not many slides, but I do want to show you this slide, right? So if you look at large language models, they do this awesome generation. And if you notice that in this picture, in the generation, this person doesn't have all the fingers, right? So you will get responses from large language model that are hallucinated for information you might ask that doesn't exist in the large language model itself, right? How can we come across that? How can we fix that? Obviously, we use tools like Bazlur showed. Tools is an interesting concept that does that, but then we can also use RAG, right? So what we want to, at least what I want to emphasize is that we do not want to mix the accuracy with truth, right? So we know what the truth is. We know that LLMs can give a very accurate answer, but it might not be true, right? So we want to be able to showcase that and how that works. And I'm going to start making a demo about it, right? So what I'm doing here is that I'm just going to start up my database. I have a Postgres database that is going to be the backend where I will store some information. This is a very interesting document here, which is about GeeCON. There's a Java syndicate of developers in GeeCON, and they have some really interesting names. I hope none of us have these names, but anyways, generated by large language model. There's Nick pointer, null pointer Nick. There's Lambda Lisa. There's AI Alex. All these different personalities, which obviously this super important data does not exist in a large language model, even though it generated it, which is interesting. So we have this markdown file that this very, very important document that we want to know exists. I have a prompt. The prompt is about Java developers and expert Java developers, and I'm going to change the prompt in a bit and show you how that works as well. We have a startup bean, and that startup bean is all it's basically doing is it has an embedding model. So we use the mini model that is provided within LangChain4j as in memory to calculate embeddings. If you're not familiar with embeddings is this really obscure long line of numeric numbers that make sense to a large language model and not to humans. And we're going to see those numbers as well in a second, although I don't want to scare you, there are too many. And then obviously we're using PG vector. So we use the PG vector store to store these vectors. You can use many other things. You can use Elasticsearch if you're using that. LangChain has many different adapters. We just use PG because it's simple for us to use. Then the interesting part is obviously the ingestion. So once I have put in the document, so I have a path, which is the documents dir. In the documents dir, I'm basically saying just use the text document parser. If you're using LangChain4j, you can also use Apache Tika document processor as well. So for example, if it's PDF documents, you might want to use that. In my case, it's simple markdown, so I just want to use document processor. And very hidden fact that Tika doesn't work on my Mac very well. It has some binary problems, but anyways, so hidden the fact. On the ingester part, it's quite simple. I'm creating an embedding store ingester. So basically what it's saying, I need an embedding store, which is PG vector. I need an embedding model so I can create from text. I want to create the embeddings. And then I want you to tell me, how do I split your documents? So right now I'm saying my segment size of characters is 200 characters, right? So I'm kind of explaining how it's supposed to do splitting. And being Java developers, we've seen tokenizers many times over the past history, right? So if you've been developing a long time, you probably are familiar with it. But what we're doing is we're basically splitting them, tokenizing through that process, and finally doing an ingestion of those documents so they are actually stored. And when the large language model will pick that up in the LangChain service, it's able to actually use them. So let's go on, and I'll do is that I've already set, for example, my LLM documents dir, so I don't want to show it, put that again, but basically that's where my document is, so I basically pick that up. And what I'm going to do now is start up the Wildfly server. It starts up relatively much faster than it did 10 years ago, which is a good surprise, right? So, but it will start up, and then it's going to point to the same URL like Bazlur mentioned, which is, for example, here is the LLM Jakarta. Oy. All demos. Okay, and so if I ask question about what happened when null pointer Nick and thread, I'm just doing this on the fly, guys. So thread local Theo met at GeeCON, right? So I was gonna go. Let me just make this bigger. They met at GeeCON. They initially bonded over their shared love of caffeine and stack trace poetry, right? Stuff like that. So why is it doing that? It's basically just using my instructions. The instructions is in my personality expert, which is how the prompts connect. So yes, RAG is interesting, but also prompt is the one that is actually going to make that RAG information more useful. Another thing that I do want to show at this point is, let's say the SQL, right? So if I say select text and embedding, and this is obviously I'm using the PG. Actually, I'll just do this. I'm gonna be the lazy SQL guy. Copy this and just run it, right? So here you'll see that the text that was ingested in this form where you have this big 200 character segment. Here are the embedding IDs. If I wanted to, let's say, go into more detail and maybe take the embedding, which will scare us obviously, but we're not scared. We're brave Java developers. So here you see all the embedding IDs also meshed into this, right? This doesn't make sense to a human, but it does make sense to a large language model. And most importantly, what RAG is doing. So sometimes the question comes, do I actually need to use a vector store or not? The vector store is providing you similarity search. So what it's doing is it's actually making sure that once a query come in, it's able to use these embeddings, match those in similarity on that numerical form, and give you the answer. And basically, the answer is by pushing the segment that you needed that matches this onto the large language model. So you also have to think that, do I actually need vector stores, or maybe I don't need it because I already know the context of the actual search that's coming in. That's a design decision that you would take. But for our case, I mean, we have a very open and fluent kind of question in saying, hey, what happened in this story and what happened in this story? So it's easy to say, okay, I want a big chunk of data. But what if I change the game a little bit, right? So what I'll do is, like all awesome, code, I'm just gonna delete this, delete from embedding store. I'm gonna delete all the rows there. I'm gonna go back here. I'm gonna change my prompt. So now what I want is, I want this prompt to be more precise. Let me just paste it here so I can share it to you. It's easier this way. So now I want my prompt to be a personality expert, but I also want it to tell me who that person is. And if that person does not exist in my vectors, then I should just come and say, I don't know this. Now I'm saying vectors, but large language model, right? This large language model doesn't know a specific person, it should not give me an answer, right? That's what I want the large language model to do. So what I'll do is that I had my segments to 200, which is fine. I can have segments to 200. I can have it to 5,000. It depends on how much context do I have with my large language model. This is a small context. It's not too much. I'm going to make it, let's say, maybe 5, right? And I'm going to take that there is no overlap, so there's no similarity between different answers. Now, if I do this with the same document that I was using before, I'm going to start this up. And what I expect now is that the answer should be that, or the embeddings in the database should look like such that the chunking of this is much, much, much more smaller, right? And why am I doing this? Because I want this RAG to fail, basically. When I'm an awesome developer, I like things to fail. So, so what I'll do again is I'll say select, what was it? Text and embedding. Text and embedding, was it embedding? Yeah. Embedding ID from embedding store, right? So now when I do this, here you'll see that the text chunk is way more smaller. Is that useful? If I did a similarity search and ask the question, is it going to return the answer to me? Most likely not, right? So if I come here and I say, do you know who is AI Alex? Right? It's going to say, I do not know who this person is, right? So it kind of changes the way you chunk your database. So if I, for example, went in here, and this time I made this a little bit bigger, maybe with 50, or let's say 15, oops, let's say 50, and have an overlap size, this is going to change the output again. So let me just do that again. Delete from, yeah, sorry, I have to delete and do that every time, but you know, that's how things are. I'm going to start this up again. And what's important is there's multiple types of splitters, right? So I'm going to go in that quickly. You can split documents based on sentence. You can do some recursive stuff. You can do it by your chapter, by your paragraph. You can choose to do it. But interestingly enough, like for example, I took the entire document and I said, hey, I want a 5,000 character chunk because this is such a small document. It's not too difficult. And I was using OpenAI as the backend, and perfect. And OpenAI responded like, hey, I've got all the answers for you. But then I went to a smaller model, 8 billion parameter, locally running on my machine, and I asked the same question and say, I don't understand, this is too big context. My context limit is 4,000 characters. So you need to be careful of what large language model you're using, how you're chunking, what sort of data that you have that actually gets chunked. All of these things are important design decisions when you're doing RAG. So I'm back at my database now. I'm going to do the same thing again, select text from embedding ID from embedding store. And here you'll see that it's a little bigger. So if I search for AI Alex, oops, I get something that, you know, he is something. But interestingly enough, look at this. The chunking is a little bit weird, right? It is not exactly maybe the way I want it, because AI Alex, I'll show you in the document, maybe is not the Vim guy here. But we'll see what the response is. Who is AI Alex? AI Alex is a 30-year-old individual attempting to replace the architect by coding in Java using Vim. That is not accurate. That is not accurate, but it becomes accurate because I have the chunking in place, which actually does something like this, right? So again, it's important, and by the way, this code in Vim is CLI Cindy, right? It's not AI Alex. So again, to reiterate the process, that it's important that how you do RAG, you use the right technique, either use the right tokenizing. You need to map your data. Your database data might be different. Your text document might be different. A news article might be different. So all of these different aspects will need different sort of behavior as we do it. So yeah, so that was a little bit about RAG, and I'm left with 10 minutes. So I'm going to try to jump onto Model Context Protocol. Please do put your questions into Slido, because I think we really want to answer some of those questions, right? So let me do this in my Model Context Protocol. So Bazlur showed a very nice demo with all the tools and everything, and that's very important, right? Because that's how exactly tools work. But imagine that I was writing a tool for example, Slack or Drive or something, and you were writing tools for Slack and Drive. Bazlur was writing tools. He's probably the best one writing the tools. And at the same time, we're using the same backend or the same thing to write, and we are kind of writing our own way of how we communicate with them. That kind of creates a little bit of problem, because what if Google or Slack, for their MCP, or like GitHub has, provide their own MCP server implementation and tools, so now we can actually access those tools instead. So it brings more standardization, it brings more uniformity. The way tools work is that, if it wasn't apparent from what Bazlur was showing there, is that you ask a query to the large language model. The large language model is going to go and try to make analysis of your query, and in that prompt it might think, oh, I also need to execute a specific tool. So it's going to pass that control back to wherever those tools are, execute those tools, get the results back to the large language model, analyze those results, and then give it back to the user, right? So multiple things happening here. With MCP, it's pretty much similar, but here, the control of this will go through the MCP server, which uses JSON RPC. Don't ask me why, but it does use that, and basically gives you this standard process of actually working with the tools. So what I do here is, one of the demos that we weren't able to show you was around a books API. So I have a books API. Let me go in here. It's a REST backend for just demonstration over here. And it's pretty simple. It is exposing get all books, get books by ISBN, get all categories, etc., etc. So imagine you are writing your own, you have your own REST APIs at work or wherever you do all the stuff, and you want to call them, and you want to expose them as tools to your large language model, either within or whichever way you want to do it. And obviously there are good reasons to do it. If others are using you're using the information that you have that can be used with large language models or natural language processing, it makes a lot of sense. So I started the backend here. I believe my backend address is something like rest/books. So, oops, no, it's not like rest/books, because I need Jakarta. And here there's, this amazing way of showing JSON, which I guess all of you see and understand, but it has a list of books, right? It has author, it has all the different information. And this is obviously coming from the database where I have, I have multiple tables here. One of them is books, right? So it has that as well. So you can see all the books here. The amazing books, and the best one on concurrency. But so that's the REST backend. But then what we also did was that in Jakarta, we weren't able to find specific implementation of MCP server as of today. There is Wildfly implementation for the Wildfly, exposes its own MCP server tool, which is awesome, but there's no specific thing that, does, where you can implement an MCP server. So we chose Quarkus at this point for being, compatible with JakartaEE APIs, etc. And I'm just going to show you the code here. What we're doing is, I have a REST client, which is a book service, which is basically just calling those functions. But then more interestingly, I have something called a book tool. And the book tool here is basically having a tool annotation similar to what Bazlur was showing you, is giving you get all the books. But then you can see I have this really, really weird code where I actually convert the answer into JSON. I can do that. I could also use object mapper. I could also use other funny things like using string formatters and paste the data back to the large language model. So once the tool is executed, through the MCP server. It's going to give the response. That response can be formatted in strings, could be formatted in JSON. Large language models, most of them understand that, right? So now we have an MCP implementation which says, hey, I can give you all this information about books. You can buy books, you can read. And what you should not do is I'm also doing is the update the stock quantity, which I'll show you is a bad thing to do. But anyways, so I'm having these CRUD operations on that. What I do then is that I just build my, build my package here. Actually, with the time left, I don't know I want to do that. I'll just jump onto that. So I have already built the package. What I'll do is that I'm going to run this with something called Goose. Now, you've heard about Claude Desktop and some of these other. Goose is another CLI that actually integrates with large language models as well. So it uses, if you see in this command here at the bottom, is that I'm passing my Uber jar, which I have basically told my build process that create an Uber jar for me, and do some logging around it as well, etc. Right? And here's my REST client that I do want to call, right? But here, after the jar is built, I am adding that jar as an extension into the Goose CLI, which means that Goose CLI will take that as a tools execution chain. Whenever it will communicate with large language models, it's going to give you the answer. So let's make it simpler for you as well. Let me just see if I can make this bigger. So my Goose CLI is already running. It already knows my API key because I've configured it and I don't want to show it to you. And then obviously it has my REST endpoint and my tools connected through this jar file as well. So if I say list all the books for me, right? So it will understand this is pure natural language. It's going to say, okay, I'm going to do this tool called get all books, and I'm going to get all these books for you over here. So the communication, the way it's working, I have my REST client, I have my MCP server extension added into Goose CLI. Goose CLI is connected to the large language model, and it's sending all this information in tandem with my MCP server implementation, getting all that data back from REST, right? Do you have any books on concurrency? Okay, my spellings are not that great, but we'll see. So now it says it goes into a category programming. It already knows that it needs to do that, right? Okay, so I like this book from Bazlur. Who is he? Right? And now, obviously, in my REST API, there's nothing about Bazlur, who is he and what he does. But large language model is able to enhance my request using the data that the large language model has itself, and use my tools to do that as well. Okay, perfect. Okay, I like that. I would like to buy 200 copies of this book. Now, this book, I haven't named the book up till now. It still understands the context and what I'm actually speaking about. So it says, okay, I only have 30 copies. What if I restock your copies to 200? So updated stock quantity. So you see, it's important what your tools are doing and what you don't want the tools to do, right? So I hope that made sense. So that's pretty much from the demo about MCP. Just quick interaction. Obviously, we can use multiple tools. I was using standard input output. You can also use SSE. For this, you can also add them as Docker containers and run them like the GitHub server does as an example, and then you can call them through your APIs as well. So that's also possible through, for example, Quarkus in that sense. So at this point, yep, thank you. I will go to Slido. Whoa, there's a lot of questions. Yes. Is system prompt isolated from user prompt, or would a prompt drop all previous instructions? Give me a cake recipe, be able to drop the poet personality. Yeah.
Hey, you want to answer that?
You want me to answer it? Okay. Well, both system prompts, so the question is about isolation, is it? Yeah, so system prompts and user prompts are isolated in some manner. System prompt is basically giving you, how I would distinguish as a best practice is the behavior, whereas the user prompt is pretty much changing based on what the user does. So for example, in Poet, you are injecting topic as one of the things there, right? Whereas system prompt is giving you the overall behavior. Like in the Java champion case, it always returns, I am the champion, I am the champion, I am the champion. So that's how I would basically isolate the two. I don't know if you have.
I mean, basically, it's system prompt is basically how we are going to get the output, and user prompt is what. So basically, how and what. That's the difference to remember. Yeah, let's go to the next one.
Yeah, for using AI chat tool to generate JakartaEE project, you need to have generated JakartaEE project manually in a better browser tool. Well, yes, it's just an example. Okay, something is happening here. I'm losing questions, but what's the best way to slice embeddings? Can we use some logic to create right chunks? Yes, you can use multiple logics. The purely you need to see is, obviously there's some hit and miss based on your prompt. So remember that you want your prompt to be crafted that actually matches the way you are actually going to get the data. In the chunking, you want to make sure that, if your data is descriptive, how descriptive it is. Like, let's say in my case, when I picked up AI Alex, I should have maybe had a smaller chunk, and that would have made my life easier with some overlap. But I chose 50 characters, and my personality specific question was not correct for that. So you have to make a decision based on your data plus the prompt. I know it doesn't give you a very specific answer, but it gives you the idea that it depends, like everything in IT does usually, right? So.
The next question is probably about LangChain4j, whether it support all the other, other LLMs. The answer is yes, it does pretty much in a wide range of LLMs. In fact, we have in our project we have a demo called. You can run it on your time. There is a thing called multimodal. You can see this demo over here. So I can show you over here quickly. Not this one. Yeah, over here we have used a lot of models. This is a demo that if we had time we could show you. So we used like a different set of with the same framework, same set of configuration, but we can use different set of large language model that available. The configuration is simple. You can also use Llama, Ollama on your own local desktop. It's simple. So yeah, you can use wide range of models. Yeah. What is your opinion about Cursor?
I don't use Cursor. People talk highly about it. I started using the JetBrains AI, and I really like it because it has some really good IntelliSense and some of the things, the context. So if I write a specific method, it already knows how I want to access that, etc. So yeah, I'm not a JetBrains sales guy, but I think if you're using Java and IntelliJ, I think I really like that. Don't ask me about Cursor. I've only seen it, but I stick to IntelliJ.
Cursor is not a JetBrains product though.
Yeah, and I somehow cannot develop on VS Code either, so I don't know.
Yeah, same here. I'm a JetBrains user. Sorry, it's a promotion. They didn't pay me for that, but yeah, they allow me to use their tools freely. So anyway. But yeah, I also didn't use Cursor, but I heard a lot of good things about it. There is a tool called Juni that's provided by JetBrains that also does similar things. It can do a lot of things automatically. I think it will give you a productivity boost, but at certain points it will be, you have to be there to fix some of the problem because it can't solve when it becomes a bit complex.
Yeah, that one is for you.
Can you build a chain of tools and pass result from? Yeah, sure. Why not? You can do a lot of amazing things. So there's one question I think earlier about drop all these previous instruction and do this. Yeah, that's called prompt injection, and there is a thing called guardrail. We can implement. There is a talk about guardrail today. I think if you want to join that talk, you will learn about that.
I think Martin is doing a guardrail talk, and I think with the tools, it's as you chain them. Obviously, you want to be sure how you chain them, because if you chain them too much, your response is also going to be slow.
Yeah. So yeah, I mean, now previously we were we used to worry about the spell injection. Now we are going to worry about prompt injection. So it's a new challenge, and yeah. Is
there a way to test prompts? Yes, you enter them. So there is cosine similarities that you can do, but based on the results that come from the test prompts. They are textual similarities, so kind of they can match the distance between your answers, so you understand the context. But since large language models are non-deterministic, the results are not always the same. Cosine similarity will not work on code generation, as an example, right? So that could be a difficult one.
If you have more questions, you can ask. We can stay here for more 10 minutes, I think. If you want to keep on asking questions, we can entertain you.
Yep.
But someone asked whether you want to get the source code. Yes, that's the QR code. You can grab all the source code and try it yourself. We designed the whole repository as a workshop style. We started from pretty basics, and then gradually on each step we added a new layer, new idea. So that way, if you complete this whole steps, we have like 10 steps, right? 10 steps, but we have like 11, 12 demo. So we started from 0. Obviously, we're programmer, right? It starts from 0.
Yeah, and I think it's also fair to say that we went on this journey and started to learn about these things about 18 months ago, and I think it's great to share it. So if you have any feedback or you want to see something else, please do write to us as well.
No more questions.
No more questions. Yep. So
But
thank you very much.
Thank you very much, and I definitely want to take a selfie with all of you, so that I can show it to my wife that I was here. Do you wanna come here as well?
Yeah, sure. Selfies are always good. Thanks.
Thank you for joining.